So this unit is 10 lessons. We should be done by the end of the week, possibly Thursday or Friday. And we'll have a test either when we get back or right before we leave. So let's begin. Lesson 1 deals with a concept called inequalities. And we're going to go and first look at the types of numbers that are available to us. Well, when we start these lessons, we have to come up with the concept of different types of numbers. We have a thing called the real numbers. Now, real numbers break down into two types of numbers. Ones, which are called rational numbers. And rational numbers are of the form P over Q, i.e. fractions, and irrational numbers. Now, irrational numbers are numbers that cannot terminate or cannot be represented by a fraction. So those examples are pi. Okay, so 3.14159, those numbers that go on forever. Another example would be the square root of 2. Now, when we talk about irrationals have a symbol Q. For rationals, we have the letter Q. Q for quotient. Okay. From here, rationals break into two parts. Ones that are called non-integers and integers. And integers, you've seen them all. And from here, our integers break into two other parts called negative numbers. We have a 0, and our integers break down into positive numbers. Okay, so when you think of all of these different types, all of these different types of numbers represent the different sets of possible numbers that we can basically represent for any number in mathematics. Let's talk about inequalities. Suppose that A is greater than 0. In English, you would say A is positive. When we say A is greater than or equal to 0, we also mean that A is non-negative. When we say A is equal to 0, you can also say this. A is neither positive or negative. If A is less than 0, we just say A is negative. So we're going to make sure that when we talk about these things, we look at things such as solving inequalities. Here is what you need to know. There are some key concepts that you need to remember. So for example, if the value A is less than B, then A plus C is still less than B plus C, regardless of whether C is either positive or negative. But if I have something like this, AC is less than BC, that means our C value must be greater than 0. If I have AC is greater than BC, that means that we had our C value being less than 0. So here's an example. Suppose I have 1 is less than X, right? And I have C being bigger than 0, right? But instead I say C is equal to 2. That means that 2 is less than 2x. We don't flip the equality. But if I had something like this, suppose 1 was less than x, and I was going to apply C to everything, but C was, say, equal to negative 2. You would apply negative 2 to this and this, but what would happen is the sign of the greater than sign would flip. So I'd have negative 2 is greater than 2x. So we would actually change the sign if our C value that we were multiplying against each of the terms was negative. Okay? The next concept we're going to study is a thing called interval notation. Sometimes you will see something like this. X, here's our example. Let's say I have 1 is between x, but it's less than or equal to 2. If I want to write this in interval notation with all of these numbers and symbols, I would write this. Okay, so on the left side of my equation, I would have an interval. So an interval could be a set of points that this thing exists for, okay? So here is what I would write. This is our first test. The interval notation is, well, for the less than sign, we're actually saying the following in our number line. So if I had a number line, this was the number 2, and this was the negative 1. If I was looking at this using a number line, my number line would have a circle at 1. And then my points, because I have an equal sign here, a less than or equal sign for the boundary of 2 would have to be a circle. And I would join these lines to say that I would have every point between here and here, but not including negative 1. Now, for the interval notation, based on what you see on that number line, you would write open bracket negative 1 and 2 with a squared sign. Now, what that means is the round sign means that we have something that is greater than. If I had a left sign, it would mean less than. Now, this side here, the square bracket, means less than or equal to. Okay, here's another example for our interval notation, because we're just getting through the basics here today. Let's say I have -2 is less than x. So if I was looking at a number line representation of this, I would have the number 2. Now, I would not have a filled out line for -2. I would have a circle for my line, for my number line. Now, I'm saying x is less, I'm saying -2 is less than x. So what that means is, I could rewrite this, couldn't I? I could rewrite this to say x is bigger than -2. Now, all that means is that we've got all the points greater than -2. So to represent this in interval notation, right? The interval notation is this. So because we have -2 and it's an open circle for our number line, we would write a rounded parentheses, and then we would have -2. But in order to show that it goes on forever, we know that its endpoint is infinity. So it never quite reaches infinity, but it will go on forever. Does that make sense? So the reason why it looks like this second bracket opening up forever, is because infinity never has an endpoint. So now let's go and do some simple math that deals with solving and graphing. So what we're going to do now is we're going to solve and graph the following inequality. So let's begin. 2, 5 minus 3x is greater than 3, 4x plus 2. So when we do this, what we're going to have to do is we're just going to have to distribute the 2 into our bracket, this into our bracket again, and we end up with 10 minus 6x is greater than 12x plus 6. Now, what I want you to do is I want you to move all your letter terms to the one side and all your numbers to one side. So you're going to get -6x minus 12x is greater than 6 minus 10. Now that I have that, what we need to do is we'll simplify. So now we have -4 is -18x. So I get -18x is greater than -4. So when we originally were working with equations, we would divide both sides by -18 and we'd be done. But I need you to remember, anytime you see a negative number being divided in an inequality, we have to reverse the equality. So let's make sure that we remember that. That's something that we need to always do. So when we're trying to solve for x, find our equation for x, for which this is true, we have to flip the sign. So we get -18x divided by -18. Instead of greater than now, we have less than -4 over -18. We'll simplify both sides. So -4 divided by 18 is 2 over 9. And -18x over -18 is x. And there we have our solution. When you hear the term solve and graph really means one of these three things. So when we solve, we already solved. We found the x values for which our stuff works. So in this case, we got x is less than 2/9. Now, you could also write, based on this, set notation that we studied a while back. X such that, that's what this bar means, such that, well, our x values are less than 2/9. And we can say, when we get to university, that x belongs to all real numbers. So it can be any type of number that comes up. So all the fractions, the decimals, the irrational numbers that we talked about earlier. Or we could write as our solution is, and we can write this in interval notation from before. Well, it's less than negative, so we can write negative infinity and 2/9. And now let me explain to you why this is. If we drew a number line that showed what was actually happening, we'd have our number line here. We'd have our point 2/9, and we would have a circle because 2/9 is x is less than 2/9, and when we draw our arrow, we would draw it moving to the right, and it would go to infinity. And that's all we have. Pause the video and copy this down, and we'll move on to the final topic of this lesson. So this problem is exactly how we used to do it when we were solving for x. Okay? Except what we're going to do is we're going to get rid of our fraction first. So if I look at this problem, it says 2 is less than or equal to this thing in the middle, 4x plus 2, which is less than or equal to 10. So what I'm going to do is I'm going to actually take a moment and go through this problem and then explain it to you. So the first thing that we're going to do is we're going to multiply everything by -3. So multiply this by -3, this whole fraction by -3, and this number 10 by -3. By doing so, you're going to get -6 for the outside term. Then you're going to get 4x plus 2 for the middle term and -30 for the end term. Now, I'm going to highlight this in red so that you see it. Now, remember, when we multiplied or divided by a negative number, right? What it did was it flipped the equality sign. So instead of less than or equal to, now we've got greater than or equal to and greater than or equal to. So you need to remember, if you ever have to multiply or divide an entire equation by a negative number, you need to flip the equalities. Okay? I'm just going to highlight that here. And so then I've flipped my equalities. What we have left to do is we have to isolate x like we would normally do. If I have x plus 2 and I want to get 4x plus 2 and take the 2 away, I'm going to subtract 2 from the middle, subtract 2 from both ends. So that means we're going to have -8 is greater than or equal to 4x, but greater than or equal to -32. Now, to make your life easier, just make it so that you have everything being less than or equal to in our equation. And all I'm going to do is just rearrange this equation by flipping everything from right to left instead of left to right. So we're going to have negative 32. We still maintain the equality. You're going to say is less than or equal to 4x, but less than or equal to negative 8. Okay, now that I've done that, we're going to divide both sides by 4. Divide everything by 4 to get x by itself. Now, because x is positive, sorry, not the x value, the 4 is positive, we don't have to flip the sign. So we end up with negative 8 is less than or equal to x, which is less than or equal to negative 2. And we're done. So you could literally say that this is your solution, or if you say this in interval notation, you would say the solution is. Now, you're saying that the x values are between negative 2 and negative 8. So I would draw my number line, negative 2 and negative 8. And because we have an equality sign, we can put our circle here at both ends. But then because they are equal, we must fill in our circles. And because it's less than or equal, technically you've got a line going this way. And because x is greater than or equal to negative 8, you've got another line going this way. And what that forces us to do is we can just join those two lines and say that and show that all the points are between these things. So you could literally say that this is your solution. Your homework is going to be, is page 9, number 1 to 33, and that's odd. So that's every other number. So you're doing 16 questions, and we will start up the next lesson in the next hour.